And this is our next question. So in this question you can see there is a diode placed between 2 volt. So here you have 9 volt and 10 volt. You can see 10 volt is more powerful than 9 volt, so current will basically try to flow in this anti-clockwise direction. But in this anti-clockwise flow of current, you can see the diode has been placed over here and it will be in reverse bias. So in reverse bias the current passing through the diode will be 0, so that's why 0 ampere will be our answer. Okay, and this is the next question. This is basically a circuit of XOR gate. Okay, XOR gate. In XOR gate, you remember, if both the input output is different, that means 0 1 or 1 0, so output will be what? 1. Okay, and if it is 1, so 1 and 1 in the question, option C and D you can see, so we can eliminate option A and B. Okay, if both the output input is same, 1 1 or 0 0, so output will be 0. So in the option C we can see 0 over here, so 0 will be right answer. Okay, next move to the next question. Let us move to the next question. So in this question you can see a force has been applied over here. If you push force on the small mass, so in this contact what will happen, this force, some part of this force will be applied over here, and this force will push this 2 mass body in the right direction, and some part of this force will be applied over here, and this force will be applied in this surface, and that will try to take this body in the right direction. So this force will be most powerful, so this F will be what? Greater than, if in this contact the force is N1, so F will be greater than N1, and in this contact if the force is N2, so N2 will be what? N1 will be greater than N2, so option A will be our right answer. Okay, so in the next question you can see a mass has been placed over here which has thrown on the surface in the right direction, and it will hit on this spring and spring will shrink. So maximum distance the string gets compressed through is what? That means the maximum decrement in the length of K will be what? Okay, so the maximum decrement of the spring will be what? So you know, if you push this spring by some amount, if you shrink string by some amount, suppose this is the amount of decrement of length, so it will be basically what? The work done will be basically half K x square, and this work done is equal to what? Is equal to change of kinetic energy. If the initial kinetic energy is what? Half m v square. The mass of the object is m and velocity of the object is v square, and after touching this surface the velocity will be 0. Okay, final velocity will be 0. So this half k x square will be equal to half m v square. So half k x square will be equal to half m v square. So if you cancel half and half, so we'll get x equal to what? M by k root over, and outside the root we will have v. Okay, so this is the solution of this part. Let us move to the next question. So in this question you can see the radius, velocity and energy is given. So you will have of hydrogen atom, okay, given. So we will have to find the relation between R, V, N, E. So which one will be correct? So, okay, N is the principal quantum number. Okay, so according to Bohr theory, you know, angular momentum, that is mvr, is what? Equal to nh cut. So n is basically what? Proportional to mvr. If you since m is constant, so you can take it out and you can say N is proportional to VR. Since both theory has been told over here, so you can directly hit the option VR. Okay, so option A will be our correct answer. So in the next question you can see a 12.5 electron volt electron beam is used to bombard gaseous hydrogen at ground state. The energy level up to which the hydrogen atom will be excited. Okay, so in this question you can see that the energy level has been asked to find. Okay, so basically you know that sorry, give me a second. Basically you know the energy level is what, minus 13.6 by n square z square ev for hydrogen. Okay, so for hydrogen H will be 1. Okay, since the value of Z is 1 in the case of hydrogen. So basically in the question it is given the final energy level and initial energy level has energy difference called what, 12.5. Okay, so final energy level you can put minus 13.6. Since the value of Z is 1, so you don't worry about 1. So let us take the final level. Let final level is what, final level is N. So in this part you put N and minus 13.6. in the ground level you put the value of N is 1 square and it will be 5. Okay, so basically after solving this you will get N square equal to 13.6 divided by 11. So basically the value of N will be approximately 3, since it is an integer number. So basically we will have to take the close integer of the answer. Okay, so let us move to the next question. So what is our next question? It is a problem of Young double slit experiment. In Young double slit experiment, the wavelength of light lambda passes through the double slit and forms interference fringes on screen 1.2 meter away. So the value of G is given over here, 1.2 meter. The difference between third maxima and third minima is what, 0.18 centimeter. The slits are 0.02 centimeter apart. That means value of D is what, 0.02 centimeter. So basically we will have to find the value of lambda. So let us take a fresh page, then we will try to solve it, otherwise it will be haphazard. Okay, so so you know the position of nth bright fringe. Okay, for position of nth bright fringe, in bright fringe is what, xn equal to n beta. So it will be n lambda capital D by small d. Okay, so in this question it is given distance between third maxima and third minima is what, you know the distance between third maxima and third minima. Actually the distance between two maxima is what, the distance between two maxima is what, beta, and suppose this is the third maxima and this is our third minima. So what will be the distance? This will be the what, half of the total bandwidth. So it will be basically beta by 2. So it will be basically beta by 2. So what is the value of beta? Lambda d by d. So you can take 2 in the denominator, and what is the value of it? 0.18 centimeter. 0.18 centimeter. Okay, so we will have to find the value of lambda right now. So what will be the value of lambda? 0.18 centimeter. So into into lambda 2 d by d. So after solving it, you will get what? 600 nanometer. Okay, so I think you have understood it. So let us move to the next question. So this is a nice question. Okay, so in this question, examiner asked to find the plot graph between Vx, that means x component, that means horizontal component of the velocity with time. Okay, so you can see, if you have thrown the object like this way in the projectile motion, this is the x and this is the y component. So what will happen? The object, suppose the object is over here. Okay, so the x component and the y component of the velocity will be like this. This will be uy and this will be ux. So you can see the x component of the velocity, that is ux, that is along the x direction, and this x component has no relation with the gravity, and only the y component will have relation with the gravity. Okay, so in this case you can see the x component of the velocity, that means anything along the x component that will be independent of time. So time will not put any effect on the velocity of x, on the x component of the velocity. So here this B option will be our correct answer. So let us move to the next question. It is about the Rydberg constant. So what will be the relation between charge of electron, okay, electric charge, mass and Planck constant and Rydberg constant. So what will be the relation? Here you can take 1/4πε0 as 1 unit. Okay, so basically what happens, so you know the expression of Rydberg constant is m e to the power 4 by 8 epsilon naught square h cube into c. Okay, so if you simplify it, so